March 15th, 1944, 3:47 p.m., Ramatelli Airfield, Italy. The acrid smell of aviation fuel mixed with Mediterranean dust as Captain Benjamin O. Davis, Jr. adjusted the throttle of his P-51C Mustang, the crimson paint on his tail assembly gleaming like dried blood in the afternoon sun. The impossible claim had been circulating through German intelligence reports for weeks. A squadron of Negro pilots flying escort missions with zero bomber losses, their red-tailed aircraft becoming a symbol of invincibility over the European theater. Major Hans Schleif of the Luftwaffe's 4th Fighter Wing had read the reports in his cramped headquarters near Munich. The pages scattered across a wooden table stained with coffee and cigarette ash. And he had done what any rational military officer would do when confronted with such obvious Allied propaganda. He had laughed. "Schwarze Amerikaner shooting down our aces," Schleif had muttered to his adjutant, Lieutenant Werner Krupp, while crushing his third cigarette of the morning into an overflowing ashtray. "The Americans must be more desperate than we thought." The dismissive chuckle that followed echoed through the bunker, shared by a dozen other officers who had gathered around the morning briefing table, their faces bearing the confident smirks of men who believed they understood the natural order of aerial combat. But the reports kept coming, each more detailed than the last, each bearing the unmistakable signatures of credible intelligence sources scattered across occupied Europe. Flight Lieutenant James Morrison of the Royal Air Force had witnessed it firsthand during a joint mission over Austria, recording in his personal diary, "Watched the Red Tails tear through a formation of 109s like they were training aircraft. Never seen anything quite like it in 3 years of combat." Captain Giuseppe Torriani of the Italian Resistance had counted the victories from his hidden observation post near Bologna, scratching tally marks into the wooden frame of his makeshift shelter as crimson-tailed Mustangs sent German fighters spiraling toward the earth in columns of black smoke. War correspondent Ernie Pyle had filed a dispatch from an undisclosed location in southern Italy, describing the methodical precision with which these pilots dismantled German formations, their aircraft moving through the sky like red arrows fired from some divine bow of justice. The technical specifications of their equipment told a story that German engineers were beginning to understand with growing unease. Each P-51C Mustang carried 6 50-caliber Browning machine guns, capable of firing 1,000 to 60 rounds per minute at a muzzle velocity of toothy 840 feet per second, the combined firepower sufficient to saw a Messerschmitt Bf 109 in half within 3 seconds of concentrated fire. The Packard V165D7 Merlin engine generated 1,795 horsepower at 3,000 RPM, propelling these aircraft at maximum speeds of 437 miles per hour at 25,000 feet, while maintaining operational ranges of 1,750 miles with external fuel tanks that allowed them to escort bomber formations deep into the heart of the Reich without the fuel constraints that had plagued earlier escort fighters. It was the mathematics of aerial supremacy, written in octane ratings and ammunition expenditure reports that German logistics officers studied with the growing realization that their opponents possessed not just superior equipment, but the industrial capacity to deploy that equipment in overwhelming numbers across multiple theaters of operations simultaneously. The central set piece had occurred on March 24, 1944, during the massive Allied bombing raid against Berlin, when Captain Davis led 43 P-51 Mustangs of the 332nd Fighter Group through a gauntlet of German interceptors that included some of the Luftwaffe's most experienced pilots. The morning had begun badly for the American formation, with German fighters attacking from multiple angles in coordinated waves, their yellow-nosed Messerschmitts diving out of the sun like metallic wasps, machine guns chattering as they tried to break through the escort screen to reach the vulnerable B-17 flying fortresses lumbering toward their targets at 185 miles per hour. But what German pilots had expected to be a routine interception had transformed into something entirely different as the Red Tails turned into their attackers with a coordination and lethality that defied every assumption about American Negro capabilities. First Lieutenant Charles McGee had rolled his Mustang inverted and pulled through a vertical dive that brought him onto the tail of Hauptmann Friedrich Obliser, one of Germany's leading aces with 27 confirmed kills. The veteran pilot's Bf 109G6 suddenly finding itself in the crosshairs of an opponent who flew with the precision of a Swiss watchmaker and the aggression of a cornered wolverine. The engagement lasted exactly 97 seconds, during which the 302nd Fighter Group destroyed 11 German aircraft while losing none of their own. their red-tailed Mustangs weaving through the sky in perfect formation as they systematically dismantled what had been considered one of the Luftwaffe's elite interceptor squadrons. Captain Roscoe Brown had sent Unteroffizier Klaus Weber spiraling into the Bavarian countryside, his Focke-Wulf 190 shedding pieces of its port wing as it tumbled through 18,000 feet of empty air before exploding against a hillside covered with spring wildflowers. The image that would haunt German pilots for months afterward was not the sight of their comrades dying, which had become commonplace by 1944, but the methodical way in which the Red Tails reformed after each engagement. Their aircraft sliding back into perfect finger-four formations, as if the violent ballet of aerial combat had been nothing more than a training exercise conducted over the fields of Alabama, rather than a life-and-death struggle above the industrial heart of Nazi Germany. The systemic scale of American industrial production had begun revealing itself through intelligence reports that landed on Major Schleif's desk, with the regularity of morning coffee, each document containing numbers that seemed to mock the very foundations of German strategic planning. North American Aviation's Inglewood plant was producing 15.8 P-51 Mustangs per day, 7 days a week, while the Packard Motor Car Company's facilities in Detroit churned out 613 Merlin engines monthly. The production lines running 3 shifts around the clock under floodlights that turned the Michigan night into an artificial dawn of welding sparks and riveting hammers that never stopped their mechanical symphony. The avalanche of numbers buried German analysts under its sheer mathematical weight. 15,975 P-51 Mustangs rolling off American assembly lines between 1940 and 1945, supported by 2.3 million rounds of 50 caliber ammunition produced daily across 17 different manufacturing facilities, while 847 specialized training schools graduated 193,440 pilots annually from airfields scattered across 38 states. Each aviator receiving 240 hours of flight instruction on aircraft that cost $50,985 per unit, but were replaced faster than German factories could produce replacement parts for their existing fighters. The electrical consumption alone told a story of industrial capacity that German economists struggled to comprehend. The Willow Run plant consumed 84.7 megawatts of electricity per day, more power than the entire city of Munich, while employing 42,331 workers who produced 8,685 aircraft engines monthly, using 16,400 tons of aluminum, 4,200 tons of steel, and 892 tons of copper sourced from mines in Arizona, Montana, and Chile through a logistics network that spanned 3 continents and operated with the precision of a Swiss chronometer. Lieutenant Colonel William Mummier of the 33rd Fighter Group had witnessed the Red Tails in action during a joint mission over Romania. Watching through his cockpit canopy as Captain Edward Gleed led a formation of 16 P-51s through a vertical climb that brought them 3,000 feet above a squadron of German Bf-109s in less than 90 seconds. Their Merlin engines generating enough power to maintain climbing speeds that left their opponents wallowing in the thin air like swimmers trying to chase dolphins. They flew like they owned the sky, Mummier had recorded in his after-action report, filed with 15th Air Force Headquarters on March 30th, 1944. Precise, aggressive, absolutely fearless. Watched them destroy 7 enemy aircraft in 4 minutes without breaking formation discipline. These are not the pilots we were told to expect. But it was Oberst Johannes Steinhoff, Germany's 3rd highest scoring ace with 176 confirmed kills, provided the most chilling assessment of what the Luftwaffe faced when confronting the Red Tails during his interrogation after being shot down near Nuremberg on April 17, 1944. Sitting in a canvas chair inside an American intelligence tent, his left arm in a sling and his flying suit still reeking of aviation fuel, Steinhoff had stared at the floor for several minutes before delivering his verdict with the flat tone of a man describing a mathematical proof. "They are not individual pilots," he had said in accented but precise English, his voice barely audible above the sound of Allied bombers passing overhead on their way to targets deeper inside Germany. "They are components of a machine, each one interchangeable with any other. Flying aircraft that are replaced faster than we can shoot them down, supported by an industrial system that treats fighter aircraft the way we treat rifle bullets." The technical specifications that Steinhoff had observed during his final combat engagement revealed the true scope of American manufacturing sophistication. The P-51D model that had riddled his Focke-Wulf 190 with 50 caliber rounds carried 1,880 rounds of ammunition distributed among 6 wing-mounted machine guns. Each weapon capable of sustained firing rates that consumed the aircraft's entire ammunition load in exactly 108 seconds of continuous combat. While the pilot sat behind 2.5 inches of armored glass and 8mm of steel plating that made the cockpit virtually impervious to anything smaller than a 20mm cannon shell, the fuel injection systems alone represented a level of precision manufacturing that German industry could no longer match. Each Merlin engine contained 11,700 individual components machined to tolerances of 0.001 inches, assembled by workers whose average weekly salary of $47.50 exceeded what most German skilled laborers earned in a month. Operating in factories where the ambient temperature was controlled to within 2 degrees Fahrenheit to ensure consistent metal expansion rates during the precision boring of cylinder heads. Captain Charles Hall of the 99th Fighter Squadron had documented his encounter with Major Schleif's own aircraft during the mission over Anzio on January 27, 1944, recording in his pilot's log how the German ace had initially held the tactical advantage, diving out of the sun with his Messerschmitt's 20mm cannon blazing as he tried to catch Hall's formation in a climbing turn that should have left the American pilots vulnerable to a classic bounce attack. But Hall had rolled his P-51 into a split-S maneuver that brought him behind and below Schleif's aircraft in a matter of seconds. The American pilot's 6 machine guns converging on the German fighter's engine cowling with a precision that spoke of hundreds of hours of gunnery training conducted over the deserts of Arizona and the coastal waters of Florida, where student pilots had practiced their marksmanship against towed targets until hitting a 3-foot circle at 300 yards had become as automatic as breathing. The engagement had lasted 17 seconds, during which Hall fired 342 rounds and scored 27 hits on Schleif's aircraft. The German major surviving only because his fighter's self-sealing fuel tanks and armored firewall had absorbed damage that would have destroyed any earlier model Messerschmitt, allowing him to limp back to his base near Rome with his engine trailing black smoke and his starboard aileron hanging by its control cables like a broken wing. Major Schleif had climbed out of his damaged Messerschmitt with shaking hands, the acrid smell of burned hydraulic fluid and cordite filling his nostrils as ground crew members surrounded his aircraft to assess the extensive battle damage that had transformed his fighter into a flying scrap pile held together by luck and German engineering. Standing on the tarmac of Ciampino Airfield while mechanics counted 27 bullet holes in his fuselage, wings, and engine cowling, Schleif experienced what intelligence officers would later classify as his first encounter with the industrial reality that was methodically destroying the Luftwaffe one engagement at a time. The enemy pilot who had nearly killed him possessed a level of training that German flight schools could no longer provide due to fuel shortages that limited student pilots to an average of 43 hours of flight instruction before being thrust into combat against opponents who had received 240 hours of training in aircraft that burned 100-octane aviation fuel, with the casual abundance of a nation that controlled global petroleum production from Texas to Venezuela. Intelligence reports trickling back from German agents embedded in neutral countries painted a picture of American pilot training facilities that operated on scales that defied European comprehension. The Army Air Force's Training Command maintained 66 primary flying schools, 70 basic flying schools, and 38 advanced flying schools spread across the continental United States. Each facility equipped with hundreds of training aircraft that consumed 47 million gallons of aviation fuel monthly, while graduating pilots who had practiced aerial gunnery against 2.4 million feet of target fabric, towed behind converted bombers over ranges that stretched for thousands of square miles of empty desert and ocean. Captain Benjamin Davis had received his advanced fighter training at Tuskegee Army Airfield, where the 99th Fighter Squadron practiced formation flying for 6 hours daily over Alabama countryside that provided unlimited airspace for combat maneuvers. While student pilots fired 156,000 rounds of 50 caliber ammunition monthly at aerial targets that simulated every type of German fighter aircraft from the angular silhouette of the Messerschmitt Bf-109 to the stubby profile of the Focke-Wulf 190. The mathematical precision of American pilot production had become apparent to German intelligence analysts who studied captured training manuals and discovered that each red tail pilot had completed a standardized curriculum that included 65 hours of instrument flying, 89 hours of formation flying, 34 hours of aerial gunnery, and 52 hours of high-altitude combat tactics, all conducted in aircraft that were identical to the fighters they would fly in combat, rather than the obsolete training planes that German student pilots learned on Due to the shortage of modern aircraft needed for frontline units, Hauptmann Adolf Galland, general of the fighter arm, had received Schleif's combat report along with 17 similar accounts from other surviving German pilots who had encountered the Red Tails during March and April of 1944. The documents stacked on his oak desk in Berlin like evidence in a trial that was reaching its inevitable verdict. Reading through testimonies that described American Negro pilots flying with coordination and lethality that matched or exceeded Germany's most experienced aces, Galland found himself confronting a strategic reality that shattered every assumption about racial capabilities that had underpinned Nazi ideology. "They fly better than most of our veterans," Galland had confided to his aide, Major Gerhard Barkhorn, during a private meeting in his headquarters bunker beneath the Reich Chancellery on April 23, 1944. "Equipment, training, tactics, all superior to what we can provide our own pilots. We are not losing to individuals. We are losing to a system." The system that was destroying German air power operated according to industrial principles that treated military aircraft as consumer products to be manufactured in quantities that overwhelmed enemy production through sheer mathematical superiority. Ford Motor Company's Willow Run plant had achieved peak production rates of one B-24 Liberator bomber every 63 minutes, while Consolidated Aircraft's San Diego facility completed one B-24 every 100 minutes. The two factories combining to produce 18,482 four-engine bombers that required escort fighters in numbers that stretched German interceptor capabilities beyond their breaking point. Each bomber formation demanded fighter protection that consumed German fuel, ammunition, and pilot reserves at rates that exceeded replacement capacity, forcing Luftwaffe commanders to choose between defending German cities or protecting German industry. A strategic dilemma that American planners had deliberately created through the mathematical application of overwhelming force across multiple targets simultaneously. Lieutenant Robert Friend of the 332nd Fighter Group had experienced the German dilemma firsthand during the mission over Plesty on June 23, 1944, when his formation of Red Tails encountered a mixed force of German and Romanian fighters that attacked with the desperate fury of pilots who knew they were facing an enemy that possessed inexhaustible reserves of men and machines. The engagement had begun at 24,000 feet above the oil refineries that provided much of Germany's remaining aviation fuel. With Messerschmitt Bf-109s diving through American bomber formations, while Focke-Wulf 190s tried to break through the escort screen using tactics that sacrificed caution for the slim chance of achieving decisive results. Friend had watched German pilots press their attacks to ranges that bordered on suicide, their aircraft closing to within 50 yards of American bombers before opening fire. Desperate to achieve killing shots that would justify the enormous expenditure of fuel and ammunition that each sortie represented for an air force operating on increasingly limited resources. But the Red Tails had met German desperation with American abundance, their P-51 Mustangs carrying external fuel tanks that provided combat radius capabilities of 850 miles, allowing them to escort bomber formations to targets deep inside German territory while maintaining sufficient fuel reserves for extended combat that could last up to 90 minutes, without compromising their ability to return to base in Italy. The contrast between German fuel shortages and American fuel abundance had become apparent during the extended dogfight that developed over the Romanian countryside, with German fighters forced to disengage after 23 minutes of combat due to low fuel warnings, while the Red Tails continued flying combat air patrols over the target area for an additional 47 minutes. Their Merlin engines consuming high-octane aviation fuel with the casual profligacy of a nation that controlled petroleum resources from Alaska to Saudi Arabia through a network of oil companies that operated as extensions of American strategic policy. The strategic petroleum reserves that fueled American air power stretched across a continental infrastructure that German intelligence officers struggled to comprehend even when presented with captured documents that detailed the scope of Allied fuel production. The Texas oil fields alone produced 1.3 million barrels of crude oil daily, refined into 100-octane aviation gasoline at facilities in Port Arthur, Beaumont, and Houston that operated around the clock to feed a war machine that consumed petroleum products with the appetite of an industrial civilization that had transformed warfare into a contest of manufacturing capacity rather than martial skill. Captain Clarence Jameson of the 99th Fighter Squadron had witnessed the fuel abundance firsthand during a mission briefing at Ramitelli Airfield on May 15, 1944, when intelligence officers had casually mentioned that American bombers would be carrying enough fuel to reach targets 200 miles inside German territory, conduct their bombing runs, and returned to base with sufficient reserves for extended combat against interceptor forces that might pursue them for hundreds of miles across occupied Europe. The mathematical impossibility of German victory had become apparent to Oberst Hannes Trautloft, commander of JG-54, when he calculated that his fighter group consumed 47,000 gallons of aviation fuel during a typical combat mission involving 60 aircraft, while American bomber formations used 184,000 gallons of fuel for a single deep penetration raid that might involve 800 heavy bombers escorted by 400 fighters. The disparity in fuel consumption representing a strategic imbalance that could only be sustained by a nation with virtually unlimited petroleum resources. German synthetic fuel plants struggled to produce 12,000 barrels of aviation gasoline daily from coal gasification facilities that required enormous quantities of electricity and industrial chemicals, while American refineries processed 847,000 barrels of crude oil daily into aviation fuel alone, not counting the additional petroleum products needed for ground vehicles, naval vessels, and industrial machinery that supported a war economy operating on multiple continents simultaneously. The Red Tail's combat effectiveness stemmed from training programs that consumed resources on scales that German flight schools could not match even during peacetime operations. Each Tuskegee graduate had fired 4,200 rounds of 50 caliber ammunition during gunnery training, practiced aerial combat maneuvers for 127 hours in advanced trainers, and completed instrument flying courses that utilized link trainers costing $8,500 per unit. Installed in facilities that maintained precise environmental controls to simulate combat conditions ranging from Arctic cold to tropical heat. Major James Goodson of the 4th Fighter Group had observed Red Tail training methods during a joint exercise in Italy, recording in his personal diary how Negro pilots practiced formation flying with a precision that exceeded most veteran European squadrons, their aircraft maintaining positions within 3 feet of each other during high-speed maneuvers that would have scattered less experienced formations across miles of empty sky. They fly like they've been doing this for years. Goodson had written on June 8, 1944, after watching the 332nd Fighter Group execute a complex tactical maneuver that brought 16 P-51 Mustangs through a coordinated climbing turn that positioned each aircraft for optimal firing solutions against simulated enemy fighters. Perfect discipline, perfect timing, perfect execution. The Germans have no idea what they're facing. The industrial foundation supporting Red Tail operations extended beyond aircraft production to encompass a supply chain that delivered spare parts, ammunition, and replacement aircraft to combat units with the regularity of a postal service. The Army Air Force's Technical Service Command maintained 1,247 supply depots worldwide, connected by a transportation network that moved 89,000 tons of aircraft parts monthly aboard cargo ships, transport aircraft, and railroad systems that operated according to schedules coordinated through communication networks spanning 4 time zones. Captain Lee Rayford of the 332nd Fighter Group had experienced the supply system's efficiency during combat operations over Austria, when his P-51 Mustang suffered engine damage from German flak but was repaired and returned to service within 18 hours using replacement parts that had been manufactured in Detroit, shipped to Italy aboard a Liberty ship, and transported to his airfield by truck convoy. The entire process managed by logistics personnel who treated military aircraft maintenance with the same systematic approach that American factories applied to automobile production. The contrast between German and American maintenance capabilities had become starkly apparent to Luftwaffe mechanics, who struggled to keep their fighters operational, using salvaged parts and improvised repairs. While American ground crews worked with complete inventories of factory-fresh components that allowed them to maintain aircraft in conditions that exceeded original manufacturing specifications. Each Red Tail P-51 Mustang received 16.7 hours of maintenance for every hour of flight time, performed by mechanics who had completed technical training courses lasting 28 weeks at schools equipped with complete aircraft disassembly facilities, hydraulic test benches, and electrical diagnostic equipment that enabled them to identify and correct mechanical problems that would have grounded German aircraft for weeks, while parts were manufactured by hand in machine shops operating without adequate raw materials. The German pilot who had shot down Lieutenant Charles Bailey of the 99th Fighter Squadron on July 12, 1944, had discovered the extent of American material abundance when he inspected the wreckage of Bailey's P-51 and found equipment that represented more industrial capacity than most German fighters carried as standard armament. Bailey's aircraft had been equipped with a K-14 gyroscopic gun sight that cost $1,000 memorias to manufacture, and contained precision components machined to tolerances that German optical industry could no longer achieve due to shortages of specialized glass and precision ball bearings needed for the gyroscope assemblies. The pilot's survival equipment alone told a story of industrial capacity applied to individual welfare with a thoroughness that German military leaders found incomprehensible. Each Red Tail pilot carried a Mae West life vest containing 47 individual components, a parachute harness made from 23 yards of silk webbing, and emergency rations packed in waterproof containers that included chocolate bars, malted milk tablets, and water purification chemicals produced by pharmaceutical companies operating at full capacity to support military operations across 6 theaters of war simultaneously. Lieutenant Franz Stigler had encountered the full weight of American industrial mathematics on August 14, 1944, when his Messerschmitt Bf 109G6 intercepted a formation of B-17 flying fortresses over Bavaria, only to discover that the bomber formation was protected by 48 P-51 Mustangs of the 332nd Fighter Group, flying in a defensive pattern that demonstrated tactical sophistication far beyond anything German intelligence had predicted from Negro pilots trained in the racial backwaters of Alabama. The engagement had begun routinely enough, with Stigler's squadron of 12 Messerschmitts diving from 28,000 feet in a coordinated attack that should have scattered the American escort fighters and allowed the German pilots to reach the vulnerable bombers lumbering toward Munich at 180 miles per hour, their bomb bays loaded with 700 tons of high explosives destined for the BMW aircraft engine factory that produced power plants for German fighter aircraft. But the Red Tails had responded to the German attack with a tactical maneuver that transformed defensive flying into offensive warfare. 16 P-51s peeling off from the main formation to meet Stigler's squadron head-on, while the remaining 32 Mustangs maintained close escort positions around the bombers, creating a layered defense that forced German pilots to fight through multiple levels of opposition before reaching their primary targets. Captain Joseph Ellsbury had led the intercepting flight with a precision that spoke of countless hours practicing similar maneuvers over the training ranges of Tuskegee, his P-51 climbing at 3,200 feet per minute, while maintaining perfect formation discipline with his wingmen. Their aircraft moving through the thin air at 25,000 feet, with the coordination of dancers performing a routine they had rehearsed until it became instinctive muscle memory, rather than conscious tactical decision-making. Stigler had found himself facing an opponent who flew with the casual competence of a veteran pilot despite being a member of a race that German propaganda had consistently portrayed as intellectually inferior to European standards. The Negro pilot's aircraft sliding behind Stigler's Messerschmitt with a smoothness that suggested hundreds of hours of combat experience rather than the limited operational time that German intelligence had attributed to recently deployed American units. The mathematical reality of the engagement had become apparent within 90 seconds. As Stigler watched 3 of his squadron mates spiral toward the Bavarian countryside trailing smoke and flame, while the Red Tails reformed their defensive positions without losing a single aircraft, their P-51s moving back into escort formation with the mechanical precision of components in a manufacturing process designed to produce consistent results regardless of external opposition. "They are not pilots," Stigler had radioed to his remaining squadron members as he disengaged from an attack that had cost his unit 25% casualties while inflicting no damage whatsoever on the American formation. "They are machines that happen to look like men." The industrial capacity that produced such machine-like efficiency extended beyond pilot training to encompass research and development programs that treated aerial warfare as an engineering problem to be solved through systematic application of scientific methodology. The National Advisory Committee for Aeronautics operated 17 research facilities employing 7,200 engineers and technicians who conducted 24-hour wind tunnel testing of aircraft designs that incorporated lessons learned from combat reports filed by pilots like Captain Ellsbury, whose after-action summaries were analyzed by teams of specialists who translated tactical observations into engineering specifications for improved aircraft performance. Each P-51 Mustang incorporated 847 design improvements developed through systematic study of combat damage reports, maintenance logs, and pilot recommendations collected from operational units worldwide, the aircraft representing a continuously evolving weapons system that improved with each production batch rather than remaining static throughout its service life like most German fighters, which were manufactured according to specifications frozen in 1941 due to resource constraints that prevented extensive research and development programs. The Packard V-1650 Merlin engine that powered Red Tail aircraft had undergone 23 major design modifications since entering production, each change representing months of testing conducted at facilities like the Wright Field Aeronautical Laboratory in Ohio, where engines operated continuously for 500-hour test cycles, while instrumentation recorded performance data that filled 12,000 pages of technical reports analyzed by engineering teams who treated engine development as a systematic process of mathematical optimization rather than intuitive mechanical tinkering. Major Wilhelm Batz, Germany's seventh highest scoring ace with 237 confirmed victories, had experienced the engineering sophistication of American aircraft during his final combat mission over Italy on September 2, 1944, when his Focke-Wulf 190A8 engaged 6 red-tail P-51s in a dogfight that lasted 14 minutes, and demonstrated the technological gap that separated German and American fighter aircraft by margins that could no longer be overcome through the superior piloting skills or tactical innovation. Batz had opened the engagement with every advantage that 24 months of combat experience could provide, positioning his fighter above and behind the American formation, while the morning sun masked his approach. His 20mm cannon loaded with 240 rounds of high explosive ammunition that should have been sufficient to destroy at least 2 enemy aircraft if he could achieve proper firing solutions during the initial attack passes. But Captain Roscoe Brown had detected Batz's approach using combat techniques that demonstrated training far superior to anything German flight schools provided their students, the American pilot rolling his P-51 into a defensive spiral that forced Batz to follow him down through 12,000 feet of vertical airspace, while Brown's wingmen maneuvered into positions that gradually transformed the German ace from hunter into hunted. The Focke-Wulf's superior roll rate and diving speed had provided Batz with temporary advantages during the initial phases of the engagement, but the P-51's greater range and endurance meant that Brown could extend the fight beyond the fuel capacity of German aircraft, forcing Batz to choose between disengaging while he still possessed sufficient fuel to reach friendly territory or continuing the engagement until his fighter ran out of gasoline over Italian countryside controlled by Allied ground forces. Batz had chosen to disengage after burning 87% of his fuel load during a dogfight that left him with sufficient reserves for exactly 19 minutes of flight time at cruising power settings, while Brown's P-51 retained enough fuel for 2 additional hours of combat operations. The American pilot maintaining pursuit until Batz's Focke-Wulf disappeared into cloud cover near the Swiss border. Damaged but still flyable thanks to German engineering that emphasized survivability over offensive capability. The realization that had shattered Major Batz's confidence in German technological superiority occurred during his post-flight inspection at Innsbruck Airfield, when mechanics discovered that Brown's 50-caliber machine guns had scored 18 hits on his Focke-Wulf 190 without achieving a single critical system failure. The American ammunition demonstrating precision manufacturing quality that allowed individual bullets to maintain accuracy at ranges exceeding 500 yards, while German 20mm cannon shells frequently failed to detonate due to quality control problems in munitions factories operating with slave labor and inadequate raw materials. The ammunition production statistics that German intelligence officers compiled from captured American supply documents revealed an industrial capacity that dwarfed European manufacturing even during peacetime operations. Lake City Army Ammunition Plant in Missouri produced 4.5 million rounds of 50 caliber ammunition daily using automated machinery that operated with tolerances measured in thousandths of an inch, while employing 19,400 workers who earned wages sufficient to purchase the consumer goods that German civilians had not seen in stores since 1942. Each 50 caliber cartridge contained precisely 41.5 grains of IMR 4831 smokeless powder, manufactured at facilities in Tennessee that consumed 847,000 kilowatts of electricity daily to produce propellants with consistent burning characteristics that ensured uniform ballistic performance across millions of rounds. The chemical processes monitored by quality control technicians who tested random samples from each production batch using equipment calibrated to standards that exceeded German military specifications by factors of 10. The projectiles themselves represented manufacturing sophistication that German ordnance engineers could no longer match due to shortages of specialized steel alloys and precision machining equipment. Each bullet weighed exactly 660 grains and achieved muzzle velocities of 2,840 feet per second with variations of less than 50 feet per second between individual rounds. The consistency maintained through automated manufacturing processes that rejected any cartridge failing to meet specifications that German factories would have considered impossibly strict even during peacetime operations. Captain Edward Toppins of the 302nd Fighter Group had experienced the effectiveness of American ammunition during combat over Romania on October 7, 1944. when his P-51 Mustang engaged a formation of German Bf-109s defending the oil refineries at Tuskegee, the engagement resulting in 3 confirmed victories achieved through gunnery that demonstrated training far superior to anything German pilot schools provided due to ammunition shortages that limited student pilots to firing practice with machine guns loaded with wooden bullets that provided ballistic characteristics completely different from combat ammunition. Toppins had fired 247 rounds during the engagement, scoring hits with 23 bullets that destroyed 2 German fighters and damaged a third so severely that it crashed during the attempted landing at Bucharest airfield. The American pilot's gunnery accuracy representing training conducted with unlimited ammunition supplies that allowed student pilots to fire 12,000 rounds during advanced gunnery courses conducted over ranges equipped with target aircraft that provided realistic practice against moving targets traveling at combat speeds. The German pilots who survived encounters with the Red Tails invariably reported facing opponents whose gunnery skills exceeded those of veteran Luftwaffe aces who had learned aerial marksmanship through years of combat experience rather than systematic training programs designed to produce consistent results through scientific application of ballistic principles. Hauptmann Gerhard Schupfel, commander of JG-26, had described Red Tail gunnery in his combat report dated November 15, 1944. Using language that reflected his growing understanding of the industrial processes that were systematically destroying German air power. "They do not aim their guns," Schupfel had written in his neat handwriting while sitting in the squadron operations bunker near Cologne, the concrete walls vibrating from the passage of Allied bomber formations overhead. "They point their aircraft like arrows and fire with the precision of machinery. Every burst finds its target. Every target dies." The machinery precision that Schupfel had observed stemmed from training programs that treated aerial gunnery as an engineering problem, requiring systematic solutions rather than individual skill development. Each Red Tail pilot had practiced firing at aerial targets using mathematical principles that calculated proper lead angles based on target speed, range, and crossing angle tooling. The calculations performed automatically by K-14 computing gun sights that incorporated gyroscopic mechanisms manufactured to tolerances that German optical industry could no longer achieve. The gyroscopic components alone represented manufacturing sophistication that required precision ball bearings produced in quantities that exceeded total German ball bearing production by factors of 12. Each gun sight containing 247 individual parts machined from steel alloys that incorporated rare metals imported from deposits in South Africa, Chile, and Australia through shipping networks that German submarines could no longer interdict due to escort vessel production that launched 2.4 destroyers and destroyer escorts weekly from shipyards operating around the clock on both American coasts. Lieutenant Wendell Pruitt of the 302nd Fighter Squadron had relied on his K-14 gun sight during the mission over Germany on December 12, 1944, when his P-51 engaged a Messerschmitt Me-262 jet fighter that should have possessed overwhelming speed advantages over conventional propeller-driven aircraft, but discovered that technological sophistication meant nothing without adequate pilot training, sufficient fuel supplies, and reliable mechanical components manufactured according to quality control standards that German industry could no longer maintain. The Me-262 pilot had attempted to use his aircraft's 100-mile-per-hour speed advantage to execute a high-speed attack that would bring him through the American formation too quickly for effective defensive fire. But Pruitt had anticipated the attack geometry using tactical knowledge gained through training exercises conducted against captured German aircraft that allowed American pilots to study enemy capabilities in controlled environments rather than learning through combat experience that cost lives in aircraft. Pruitt's 6 machine guns had converged on the German jet during a 3-second firing pass that placed 34 hits on the Me-262's port engine. The American pilot's gunnery demonstrating accuracy that German test pilots had achieved only under ideal conditions, against stationary ground targets rather than maneuvering aircraft flying at combat speeds above 400 miles per hour, at altitudes where thin air affected ballistic trajectories in ways that required extensive mathematical calculations to achieve consistent results. The Me-262 had crashed into a forest near Frankfurt, its pilot surviving to provide intelligence officers with testimony that German jet technology represented tactical capabilities without strategic significance due to production limitations that restricted total Me-262 output to fewer than 1 to 400 aircraft during the entire war. While American factories prepared to manufacture 25,000 jet fighters annually using industrial capacity that treated advanced military aircraft as consumer products to be produced in quantities that overwhelmed enemy defensive capabilities, through mathematical superiority rather than technological innovation. The final mathematical equation of aerial warfare had revealed itself to German High Command through intelligence summaries that arrived at OKW headquarters with the relentless punctuality of death certificates, each report documenting the systematic annihilation of Luftwaffe fighter strength by an enemy that possessed not superior individual pilots, but a superior system for producing pilots, aircraft, and ammunition in quantities that reduced aerial combat to industrial accounting rather than martial skill. By January 1945, the 332nd Fighter Group had achieved 112 confirmed aerial victories while losing 66 pilots killed in action, a kill ratio of 1. A 7-to-1 that German analysts initially dismissed as statistical error until cross-referencing with Luftwaffe loss records revealed that Negro pilots flying red-tailed P-51 Mustangs had indeed destroyed 112 German aircraft, including 17 Messerschmitt Me-262 jets, 23 Focke-Wulf 190s, 41 Messerschmitt Bf-109s, 18 Junkers Ju-88s, 9 Heinkel Ha-111s, and 4 experimental aircraft that represented months of irreplaceable engineering development work conducted by technical personnel who could not be replaced at any cost. The strategic impact extended far beyond individual aircraft losses to encompass the systematic destruction of German pilot training programs that could no longer provide replacement aircrew for frontline units operating with aircraft availability rates below 60% due to maintenance problems caused by parts shortages, fuel contamination, and quality control failures in manufacturing facilities bombed by the same heavy bombers that the Red Tails had escorted through German air defenses with loss rates approaching 0%. Oberst Adolf Galland had submitted his final assessment of German fighter capabilities to Reichsmarschall Hermann Göring on February 14, 1945. The document, typed on paper watermarked with the eagle and swastika of the Third Reich, but containing conclusions that amounted to a mathematical proof of German defeat written in the precise language of military aviation rather than political rhetoric. The enemy possesses 12,847 operational fighter aircraft supported by production capacity exceeding 2,400 aircraft monthly. Galland had written while sitting in his Berlin office as American bombers passed overhead in formations so large they darkened the winter sky like migrating birds. Our total fighter strength amounts to 1,423 aircraft with production capacity of 147 monthly. We face mathematical extinction within 6 months, regardless of tactical innovations or individual pilot skill. The avalanche of numbers that buried German hopes beneath statistical inevitability included American pilot training programs that graduated 1,947 fighter pilots monthly from schools that consumed more aviation fuel in training exercises than the entire Luftwaffe allocated for combat operations, while ammunition production facilities manufactured 67 million rounds of 50 caliber machine gun ammunition monthly using raw materials imported from suppliers who treated military contracts as routine business transactions rather than desperate strategic necessities. The Red Tails themselves represented only a microscopic fraction of American pilot strength. Their 450 graduates from Tuskegee Army Airfield comprising 0.23% of the 193,440 pilots trained annually by the Army Air Forces. Yet their combat record against German opposition demonstrated the systematic effectiveness of industrial warfare applied through training programs that produce pilots with identical capabilities regardless of individual backgrounds, racial characteristics, or regional origins. Captain William Campbell of the 99th Fighter Squadron had personified this systematic effectiveness during his encounter with Hauptmann Erich Hartmann, Germany's highest-scoring ace with 352 confirmed victories, over Czechoslovakia on March 8, 1945, when Campbell's P-51 Mustang engaged Hartmann's Messerschmitt Bf-109K4 in a dogfight that lasted 11 minutes and demonstrated how individual skill meant nothing against opponents backed by unlimited industrial resources and systematic training programs. Hartmann had opened the engagement with every tactical advantage that 4 years of combat experience could provide, using cloud cover to mask his approach while positioning his fighter for a high-speed diving attack that should have ended the fight within seconds if Campbell had reacted according to standard defensive procedures taught in German pilot training manuals that emphasized individual initiative over systematic tactical doctrine. But Campbell had responded with defensive maneuvers that forced Hartmann into an extended engagement that consumed fuel, ammunition, and time that German pilots could no longer afford. The American pilot flying with the patient professionalism of a man who knew that his aircraft carried enough fuel for 4 hours of combat while his opponent faced fuel exhaustion after 90 minutes of high-power operations. The mathematical certainty of American victory written in fuel tank capacities and production statistics rather than combat skill or tactical innovation. The engagement had ended with Hartmann disengaging due to low fuel warnings while Campbell maintained pursuit until the German Aces aircraft disappeared into Austrian airspace. The American pilot returning to base with sufficient fuel for an additional hour of combat operations, demonstrating the resource abundance that allowed Allied pilots to fight extended engagements without concern for the logistics constraints that forced German pilots to choose between tactical success and survival. The industrial system that supported Campbell's casual fuel abundance operated according to mathematical principles that treated petroleum products as infinite resources rather than strategic assets to be carefully rationed among competing military priorities. American oil production had reached 7 million barrels daily by 1945, refined into aviation gasoline, at facilities that processed crude oil with the efficiency of chemical engineering, rather than the improvised synthetic fuel programs that provided Germany with 12,000 barrels of aviation fuel daily from coal gasification plants that consumed more energy than they produced when accounting for the electrical power needed to operate compression equipment, chemical processing machinery, and transportation systems. The moment of German realization had occurred in the underground bunker complex beneath the Reich Chancellery on April 15, 1945, when Oberst Nicholas von Below, Hitler's Luftwaffe adjutant, had presented the Führer with intelligence photographs showing American aircraft production facilities that operated with the casual abundance of peacetime manufacturing, while German factories struggled to maintain minimal output using slave labor, improvised materials, and machinery that broke down faster than it could be repaired. The photographs revealed assembly lines stretching for distances measured in city blocks, with P-51 Mustangs moving through production sequences that completed one fighter aircraft every 7 hours using workers who earned wages sufficient to purchase automobiles, homes, and consumer goods that German civilians had not seen since the war began. The images documenting an industrial capacity that treated military aircraft as consumer products manufactured according to peacetime quality standards rather than wartime expediency